Look at this incredible planet. This is Kepler 452b. It's one of the most fascinating planets in our entire universe, and it's easy to see why. This planet has been described as Earth's cousin because it closely resembles our own world in size and composition. Orbiting a star just like our Sun, it's in the habitable zone, meaning it has the potential to support life. It's one of the most exciting discoveries in the search for extraterrestrial life. But wait, let's go even deeper into the wonders of space. Take a look at this star system. Here we have Alpha Centauri. This system, consisting of 3 stars, is the closest one to our solar system, just a little over 4 light-years away. Now, that's incredibly close in cosmic terms. Now, let's travel even further. This is the Andromeda Galaxy, our nearest large galaxy neighbor. It's a colossal galaxy, much larger than our Milky Way, and it's racing toward us at an astonishing speed. In fact, the Andromeda Galaxy is on a collision course with the Milky Way, though that won't happen for about 4.5 billion years. And now, the most mind-boggling of them all, this massive black hole, Ton 618. This is currently the largest known black hole in the universe. It's so enormous that if it were placed at the center of our solar system, its event horizon would extend all the way to Saturn. But what do all of these incredible space objects have in common? Yes, they're all mind-blowing in their own right, but there's something more that connects them: their staggering distance from us. These objects are so far away that reaching them with our current technology would take hundreds of thousands, or in some cases, millions of years. The vastness of the universe is beyond our imagination. But have you ever thought about visiting these far-flung corners of space in your lifetime? Imagine being able to travel to these distant worlds, star systems, and galaxies before we run out of time. I don't know about you, but that's a dream I'm determined to chase. Now, to make that dream come true, we would need to travel at the speed of light. Traveling at light speed has long been a staple of science fiction. But in reality, Albert Einstein's special theory of relativity tells us that nothing can travel faster than the speed of light because, in order to do so, it would require infinite energy. And as we know, all the energy we have access to is limited. So, does that mean the dream of exploring the stars is doomed to remain just a dream forever? The truth is, it might not be. Here's the interesting part: there may be a way around this seemingly impossible barrier. What if we could warp space-time itself? This is where the concept of the Alcubierre warp drive enters the picture. The Alcubierre warp drive presents a creative solution that would allow us to travel faster than light without violating any known laws of physics. But how, you ask? Let's break it down. My name is Rajkumar Shukla, and you're watching The World of Science, now in Hindi. So, technically, you can't go faster than light, right? But space itself can move faster than light. This is the fascinating concept behind the warp drive, manipulating space-time in such a way that it would allow us to travel faster than light. The idea of a warp drive wasn't always grounded in real science. It started as a concept in the mind of science fiction author John Campbell in his 1931 novel Islands of Space. For years, this concept remained purely speculative, just a fun idea that captured the imagination. But in 1990, Mexican physicist Miguel Alcubierre came forward with a real-world theoretical model that could make it possible. Alcubierre's concept is based on the work of physicist Kip Thorne, who researched wormholes and time travel. Although wormholes and time travel are still largely theoretical and hypothetical, the Alcubierre warp drive is grounded in established principles of physics. Now, you might be wondering, how does this whole thing actually work? The secret lies in the fabric of space-time itself. According to Einstein's theory of relativity, spacetime can be warped using mass or energy, which results in gravity. Gravity is what causes planets and stars to attract one another. The Alcubierre warp drive takes this concept one step further. Instead of trying to accelerate a spacecraft to the speed of light, we would warp space itself, bend and stretch it in such a way that two distant points in space would become connected by a shortcut. This means that we could travel long distances by crossing the shorter path, rather than having to physically move through the space between. The warp drive would create a bubble of spacetime around the spacecraft. In this bubble, the space in front of the spacecraft contracts, while the space behind it expands. This creates a wave in spacetime, much like a ripple moving through water. The spacecraft would then ride this wave. It's a bit like surfing, but on a cosmic scale. Using this method, the spacecraft could travel faster than the speed of light, but without actually breaking the laws of physics. In reality, the spacecraft wouldn't be traveling faster than light. Instead, the space around it would be moving, and that's what would make it seem as though the spacecraft is moving at superluminal speeds. This is what makes this idea so exciting. We would be able to cover unimaginable distances in a fraction of the time. Imagine traveling to distant stars in just a few months or years, instead of the thousands or millions of years it would take using conventional methods. It's truly revolutionary. Now, if you're a Star Trek fan, you're probably familiar with the idea of the warp drive. In fact, Star Trek explored the concept in great detail. They even introduced the term warp factor, which quantifies the speed at which the warp field around a spacecraft is moving. For example, warp factor 1 means breaking the light speed barrier, and warp factor 2 means traveling 8 times faster than light. However, here's where it gets tricky. To make this work, an enormous amount of energy is required, more than anything we can currently produce. To generate this energy, the spacecraft would need a warp core, something akin to a nuclear reactor, but on a much grander scale. Matter and antimatter, or other exotic particles, would need to be collided at incredibly high speeds, releasing vast amounts of energy. Now, let's rewind a little. As I mentioned earlier, this warp drive concept was purely speculative until 1994, when Miguel Alcubierre proposed a solution to Einstein's field equations that closely resembled the Star Trek warp drive. Alcubierre suggested that traveling faster than light would only be possible if the energy density around the spacecraft was less than that of vacuum energy, which is essentially negative energy density. In simple terms, this negative energy density creates an anti-gravity effect. Instead of attracting matter like gravity does, it pushes matter away, allowing us to manipulate the space around the spacecraft. Using this negative energy density, we could theoretically create the spacetime bubble that is necessary for the warp drive to work. Now, if you think about it, the spacecraft isn't actually moving toward the destination. Instead, the destination is moving toward the spacecraft. This is a truly mind-bending concept. But before you get too excited, there's a major obstacle. To create this spacetime bubble, we would need an immense amount of energy. For example, the energy required to propel even a small spacecraft to warp speed would be equivalent to the mass of the entire planet Jupiter. And that's just for a small spacecraft. As you can imagine, this is beyond our current technological capabilities. There are also several risks associated with the warp drive. First, what about the radiation that would be emitted from the spacetime bubble? This could be extremely dangerous for the spacecraft, its equipment, and the crew. Second, there's the possibility that the spacetime bubble could collapse for some reason. Even a small explosion could cause the entire bubble to collapse, destroying everything inside. Finally, once you've created the bubble and are traveling faster than light, how do you stop? There are many theories about how the bubble could be controlled or destroyed, but no concrete methods have been developed yet. And last but not least, since you're traveling faster than the speed of light, objects ahead of you won't be visible. As you travel, you could collide with anything in your path because their light will never have a chance to catch up with you. That's a serious risk. Despite all these challenges, the fact that scientists are seriously studying the possibility of the warp drive is exciting. It shows that our dreams of exploring the cosmos may not be as far-fetched as they seem. So, what do you think about the warp drive? Is it just science fiction, or could it one day become a reality? Before I sign off, I'll leave you with this thought: yes, the warp drive may still seem like science fiction today, but if you look around, you'll see that many things we use today were once considered impossible. Just think about the mobile phone, the internet, or even space travel itself. As someone once said, today's science fiction could become tomorrow's science fact. None of us knows what the future holds, but it's these bold and crazy ideas that push science and technology forward. I hope you enjoyed today's episode. If you did, please like this video and share it with your fellow science enthusiasts. I'll see you in the next video. Until